Chapter 2.5, Implicit Differentiation, Day 2. Integrating implicitly with respect to t. Review. Find y prime, or more accurately, the derivative of y with respect to x. All right? As we do these problems, remember, a variable is implied inside everything. There's a function implied in the x, there's a function implied inside the y. When we take the derivative of x squared with respect to x, dy dx is 1, plus 2y, the derivative of y implied inside here is dy dx, minus 4 plus derivative of 6y is 6 times the derivative of what's implied inside of y, dy dx. Derivative of 9 is 0. Derivative of 0 is 0. From here, we want to gather all the dy dx's onto the left side. So we've got 2y dy dx plus 6 dy dx equals, we'll move the 4 over and the 2x over. So we got 2y dy dx plus 6 dy dx equals 4 minus 2x. On the left side, everything has dy dx now, so we will factor that out. We got dy dx times 2y plus 6 equals 4 minus 2x. We'll divide both sides by 2y plus 6, and we get our derivative of y with respect to x, and that is 4 minus 2x over 2y plus 6. What we're going to look at today now, we're going to continue reviewing with respect to x. We're also going to imply another variable. We're going to do problems with respect to t. Any variable can be implied in these problems. T is usually implied because it means time, and it describes a situation that changes over time. So let's start with reviewing again with respect to x on this one. All right, so we'll start this problem. The derivative of x squared with respect to x is 2x minus 3, and we'll need to use the product rule there. So it'll be the first function times the derivative of the second function, 2y dy dx, plus, again, the second function times the derivative of the first. Derivative of x with respect to x is 1, plus the derivative of y cubed, that's 3y squared times the dy dx, equals the derivative of 10 with respect to x is 0. Here, let's distribute our 3. So we got 2x minus 6xy dy dx minus 3y squared plus 3y squared dy dx equals 0. Gather your dy dx's onto the left. 3y squared dy dx minus 6xy dy dx, and move everything else over to the right, equals 3y squared minus 2x. On the left side, we're going to factor dy dx because it's common. So dy dx times 3y squared minus 6xy equals 3y squared minus 2x. We'll divide out 3y squared minus 6xy so that dy dx is alone on the left. We got 3y squared minus 2x over 3y squared minus 6xy. And there is our derivative with respect to x. All right, let's look at the same problem. This time, will go with respect to t. And our variable will be implied in both the x and the y, because it's different than both of them. So this time, with respect to t, as we look at this problem, we got 2x. Now we need dx dt, because we're going different than x. We're with respect to t. All right, use the product rule here, minus the first function times the derivative of the second, dy dt. So 3x, 2y dy dt. Minus the second function times the derivative of the first, 3 dx dt. I went minus because the derivative of negative 3x would be negative 3 dx dt. And instead of doing plus and negative, it works better to do just minus. Plus the derivative of y cubed is 3y squared dy dt equals 0. All right, same thing. Let's gather all my dy dt's onto one side, my dx dt's onto the other. So what we got, my dy dt's are here and here. So we got 3y squared dy dt minus 6xy dy dt equals 3y squared dx dt minus 2x dx dt. Here we'll factor both left and right. So on the left we'll have dy dt factored out. And we got 3y squared minus 6xy equals, on the right side we'll have dx dt factored. I'm going to factor it out on the back side. So we'll have 3y squared minus 2x dx dt. And then to get dy dt by itself, we'll divide out 3y squared minus 6xy. dy dt equals 3y squared minus 2x over 3y squared minus 6xy dx dt. Looking at another example for sine x cosine y, we'll start with respect to x first. As we do this problem, again, you should notice it's a multiplication. So we're going to be using the product rule, which is the first function for sine x times the derivative of the second function, derivative of cosine, is negative sine of y, times the derivative of what's inside, dy dx, plus the second function, cosine y, times the derivative of the first, 4 cosine x, equals 0. All right, so we have our dy dx's right here. We'll move this over. So we got negative 4 sine x sine y dy dx equals negative 4 cosine x cosine y. Divide both sides by negative 4 sine x sine y. We got dy dx equals, the 4's cancel. The cosine x over sine x is cotangent x. And the cosine y over sine y is cotangent y. Okay, last problem. Same thing with respect to t. Steps are very similar. We'll go first for sine x times the derivative of the second. That's negative sine y dy dt this time, because we're with respect to t, plus the second cosine of y times the derivative of the first, 4 cosine x dx dt, get the implied variable in there, equals 0. Get all our dy dt's on one side, our dx dt's on the other. So we got negative 4 sine x sine y dy dt equals negative 4 cosine x cosine y dx dt. And finally, we'll divide to get dy dt equals, the negative 4's cancel, cosine over sine is cotangent x, cotangent y, dx dt. All right, so in review, when you have a function where there's x and y on the same side, and it's not so easy to solve for y, you can do it implicitly, where you'll take your derivative as you go, and then anytime there's a variable that's not the same as the one you're taking with respect to, you're going to need to do your dx, dy dx, anytime you're not with respect to the variable you're taking.